Dear students, in previous lectures, we had talked about different components available in the market. Those components we can use for the purpose of making any type of embedded systems. Now, when I'm using the word embedded system, you should know what exactly it means. Let us see the definition of embedded systems. An embedded system is a combination of computer hardware and software designed for a specific function or functions within a larger system. The system can be programmable or with fixed functionality. What does it mean? It means that if you're developing some system which requires hardware and some software, and both the systems are designed to do some specific task, those type of the system is called as embedded system. Normally at our home, whatever type of the devices that we are using, like your fridge, microwave oven, TV, media recorder, etc., etc., all those systems are called as embedded systems. All those systems are called as embedded systems, and we normally use those embedded systems in our daily life. So you can see here different type of the applications are available of embedded system, like the gaming machines, the camera, smartphones, mobile phones. In vehicles we are using the embedded system, different type of the embedded systems, your normal printer, broadcasting equipments, then in airlines we are using your TV, your electronic book, etc., etc. So all these systems which has hardware and software both, these are considered as embedded system. You may think we have seen the hardware part of any particular device, but where is the software? So when you operate, let us consider one example of your television. When you operate your television, you are using remote, and when you are using remote control and you are suppose pressing the button for increasing or decreasing the volume, then in that situation you are basically giving some input in the form of some signal. That signal is being received by your television, and then the television accordingly works, and you may have seen at the bottom something has written like volume 25, 26, 27, like that. So in that way, how that volume 25, 26, 27 or whatever is coming on the screen because of some software. So that's why every particular embedded system or the hardware has some software as well as the hardware component. Let us understand the embedded system. By the definition, it is combination of hardware and the software. So if you see this diagram, the first diagram, the hardware using the green rectangle, and that hardware is embedded with the software. And when we are giving some input to that particular hardware, it provides some of the output. And to give the input or to interact with this hardware, some user interface in the terms of software or maybe in terms of remote control is available. And the embedded systems gives you the facility also that your embedded system can be part of some larger system, and you can use by connecting it. You may get the input also from some other larger system. If you see the second diagram, it is the hardware view of the embedded system, and in this particular view you can see the first part is the hardware, and then the second part is the software. So this hardware and software part is considered as embedded system. Majority of the embedded systems are designed for different functions. When we are designing the embedded system, majority of the embedded systems are designed in such a way that it can automate your manual task. For that particular purpose only we are developing the embedded system. So when we want to automate our task, we need some facilities into the hardware as well as the software so that it can do many things automatically. And for that, there are different type of sub-components used in embedded system, and those components are called as sensors and actuators. Sensors and actuators. These sensors and actuators makes, or you can say enables, our embedded system to be efficiently automate the system. We'll talk about the sensors and actuators later on. Let's move further. When I'm saying that the embedded system is something which requires hardware as well as software, you may feel or something may come into your mind that you have computer or laptop at your home, that computer and laptop is also having hardware as well as software. It means that your laptop is also an embedded system. It's not like that. Every particular system which has the hardware and the software may not be the embedded system. That can be a general purpose computer system. Differentiation between the embedded systems and the computer systems. So an embedded system is designed to perform some specific task, but the general purpose computer systems are designed to do a variety of tasks. You can use your computer for watching YouTube, for making some program using some compiler. You can watch videos, you can do some editing, and many more things you can do using your computer system. But at the same time, when we are using an embedded system, we are using it for some specific purpose. Like if you want to watch movies from some channel, then you can use your TV to watch movies. If you want to listen to songs, then either you can watch on your media player like CD, DVD player or something like that. So the embedded systems are designed for some specific task. At the same time, the general purpose computer systems can do a variety of tasks. This is the basic and major difference between the embedded system and the general purpose computer system. The second difference between the embedded system and the general purpose computer system is the embedded system may not require the operating system. The embedded system may not require the operating system, but the general purpose computer system always require operating system. I'm not saying that the embedded system will never require operating system. It may require operating system. There are operating systems in embedded system, but it may or may not require. It is not necessary that all the embedded systems should have the operating systems. But in case of the general purpose computers, it always requires the operating system. In embedded system, the response time is critical, while the general purpose computer system, the response time is not critical. Let us talk about the next differentiation. The embedded system, as it is designed for the specific task, the embedded system requires a simplified circuit, as well as the embedded system requires less memory and slow processor. When we see the computer system, it has a complex circuit. Memory requirement is very high. Also, it gives you the faster performance. So the processor requirement is higher in case of the embedded system. The embedded system comes with low cost. At the same time, the general purpose computer systems are too much costly. The applications given by the embedded systems are not alterable. It means you cannot change, the user cannot change the application. But in case of the general purpose computer system, the applications given are alterable by the user. So these are some differences between the embedded system and the general purpose computer system. Now let's talk more about the embedded system. Now we'll talk about the core components of embedded system. Core components means the components which are very much required to develop some embedded system. As we know, the embedded system is developed using some hardware and software. So the core component has two different parts, hardware as well as the software. Now the hardware is further divided into different sub-units, same as the software. So hardware is divided into different units like processor, memory, user interface, input output, and the software is divided into different parts like control software, computational extensive software, device driver, user interface, and the operating system. So this is the core component required to develop any embedded system. Let's move further and talk about the classifications of embedded systems. When we are making the embedded systems, the embedded system functions different, and based on their function or based on how they are giving you the output, how they are performing, etc., etc., the embedded systems are divided into different categories. There are different ways through which we can categorize the embedded system. Here we have taken two broad categories of embedded system, but there are two more types of the embedded system. We here normally consider basic two types of the embedded system. The first embedded system we are categorizing is based on the performance and the functional requirement. the second category of the embedded system we are taking based on the performance of the microcontroller. So based on the performance and functional requirement, the embedded systems are categorized into four broad categories: standalone embedded systems, real-time embedded systems, networked embedded systems, and mobile embedded systems. So first one is the standalone embedded system. Standalone. As the name suggests, these type of the embedded systems are standalone. They are complete within it. They don't require to be part of some larger system to function, like your microwave oven. If you give the power, the microwave oven will increase the temperature of food, whatever you are putting inside. It don't require to be part of some other system. Like maybe if it might had happened, like you need to start the microwave oven, and to start the microwave oven, you need to connect it with the refrigerator. The refrigerator will give the input, then only the microwave will work. It is not like that. That's why the standalone embedded systems are complete within. The next type of the embedded system is the real-time embedded system. When we talk about the real-time embedded system, these type of embedded systems are very, very important, because at the real time, they based on the real-time inputs, it gives you the outcome. These type of the embedded systems, real-time embedded systems, are very much important if you want to do something on the real time, and based on those inputs, whatever is coming on the real time, you want to perform some task. So these type of operations, or for these type of the activities, we may need some real-time embedded systems. The third type of the embedded system is the networked embedded system. When we connect our devices through internet, we need to use some network devices. Like you might be listening to my lecture on your mobile phone, and you are connected with the Wi-Fi at your home at this moment. Now, in this particular situation, that Wi-Fi router, you need to set up that. That is a hardware that is derived for a basic function of spreading the internet signals all over your home. And when you want to connect, you need to find that particular device, and then you can connect through that device. Once you are connected through that device, then you can use the internet signal. So to connect with the device, you need to use some of the ways and means. Maybe some router IP you will get, some ID and password you will get, that is a part of the software, and the hardware is giving you the answer. So in that way, those type of the embedded systems, switches, routers, L1, L2, L3 switches are coming, routers are coming. They are considered as networked embedded system. It enables you to be connected with the external world, your devices to the external world. Now, the next is the mobile embedded system. The mobile embedded systems are basically the portable embedded systems which can be used. You can take it anywhere and you can use it. It will not require some specific location to be placed. Simply while roaming, you can use those type of embedded system. I'm giving just an example. You have a music system at your home, that is an embedded system. Now, that music system is a mobile embedded system. You can take that music system and you can go in some other room and you can listen to music at that room. That embedded system doesn't require to be connected with some larger system, then only it is going to function. Maybe if you want to, you might have connected with the TV, that is a different thing. But in a whole, it can function completely and you can take it from one place to another place. Now, the second broad category we'll talk about, and that is based on the microcontroller or the microprocessor used to develop that particular embedded system. And based on that, three different categories are given: small scale embedded systems, medium scale embedded systems, and large scale or sophisticated embedded system. Small scale embedded system. These small scale embedded systems are those embedded systems. These small scale embedded systems are basically the embedded systems which uses 8-bit of the microprocessor and 8 or 16-bit of the microcontroller. Okay, 8-bit of the microprocessor or 8 or 16-bit of microcontroller. The medium scale embedded system. The next embedded system is medium scale embedded system, and these embedded systems are basically designed using 16-bit of microprocessor and or 16 or 32-bit of the microcontroller. And the third, sophisticated or large-scale embedded systems are those embedded systems which are developed by using 32-bit or more of microprocessor as well as microcontroller, or the controller which are used to develop the device. In case of small scale embedded system, I told you 8-bit of the microprocessor or 8 or 16-bit of the microcontroller. So two different type of processor I am talking about. The medium scale embedded system, 16-bit of the microprocessor or 16 or 32-bit of microcontroller. In sophisticated, 32-bit of the microprocessor and 32 or more bit of the microcontrollers. So here we are talking about two different things, microprocessor and microcontrollers. These microprocessors and microcontrollers are basically the core component of embedded system. And the microprocessor and microcontroller gives the brain to your hardware. And these processors are only the provides the capability to our hardware to run efficiently and to execute different tasks using the programs. So we'll talk more about the microprocessor and microcontrollers. Microprocessor is an IC, integrated circuit, which has only the CPU inside them, which has the central processing unit inside them. And because of that central processing unit, you can give some instruction to the microprocessor, and that instruction will be executed by the microprocessor and you will get the output. There are different companies which are making the microprocessors. Few of them are Motorola, and you might be knowing this one, that is Intel. And different types of the processors are developed. If you will see the evolution of the development process of your microprocessor, then you will find that we have evolved a lot. We started with 8-bit of the processor, microprocessor 8085, which was the 8-bit processor. Now we are into 128 and 256-bit of processors also. But we are using those processors commercially. At our home, we are using up to only 64-bit or 128-bit of the processor. Different types of the processor, you might have heard about the Pentium 1, 2, 3, 4. Then in the market, some new technology came that was called as the dual core or core to duo processors. Then now i3, i5, i7, i9. i9 is already in the market. It is too much costly. We are using i3 or i5 processor. If you can spend more money on the processor, then you can go for i9 or i7 processor. In addition, this is about the microprocessor. In addition, the microcontrollers are having fixed amount of memory like RAM and ROM, and the capabilities to be connected with other peripheral devices inside that. Now you will say, sir, microprocessor also has memory. Microprocessor within the chip is not having any type of memory. It is dependent on the coprocessors to be connected with the memory. So memory is externally connected to the microprocessor, and if you don't have memory, your microprocessor is not going to work. In case of the microcontroller, it is different. Within the single chip, inside that chip, the microcontroller has some amount of memory and the capability to be connected with the external devices, that is called as peripherals. It has the capability to be connected with the external devices. So in that way, if you want to differentiate between the microprocessor and the microcontroller, you can differentiate it as the microcontroller has the memory and the peripheral devices within the chip, not peripheral devices exactly, but the capability to be connected with the peripherals is within the chip. But the microprocessor requires external memory or the coprocessors to be connected with the peripherals. So this is the broad, or you can say broader difference between the microprocessor and the microcontroller. So this is about the comparison between the microprocessor and the microcontroller. So microprocessors are multitasking in nature and can perform multiple tasks at a time. For example, on a computer, we can play music while writing text in text editor. At the same time, the microcontrollers are single task oriented. For example, if you're making a washing machine, a specific microcontroller to use in washing machine can be developed. The second difference between the microprocessor and the microcontroller is the RAM, ROM, and input-output ports and timers can be added externally and can vary in numbers. It means the memory and input-output elements are not the internal part of the microprocessor. They are connected externally. So when we are connecting the memory and input-output externally, we don't bother much about the size. As per our requirement, we can increase or decrease the size of your memory. But in case of the microcontrollers, because the memory is inbuilt, so we have to be very selective. Based on our requirement, we need to select a specific microcontroller with some specific memory. That is the difference. Now, designers can decide the number of memory and input-output ports needed to develop a system using the microprocessor. But in case of the microcontroller, fixed number of memory or input-output makes a microcontroller ideal for a limited but specific task. Because when we are using the microprocessor, external memory and input-output devices to be connected, the cost of the hardware increases. And that's why the microprocessor-based devices are costly. That is not happening in case of the microcontrollers. Second thing, when we need multiple processors or we need the coprocessors to operate, the size of your hardware will get increased. If the size increases, the complexity of the circuit increases. And if we can connect with multiple devices, the power requirement increases. So the microprocessor as a whole, we can say, is more complex architecture. And the microcontroller is not having much complex architecture. It requires less power. That's why you can see your mobile phone comes with a good processor. But once you charge, you can use it for the next 24 to 48 hours because the power requirement is very less. But at the same time, when you're using your air conditioner 24/7, you need to be connected your refrigerator with the power source, and it consumes more amount of the power as compared to your other embedded systems. Now we'll talk about automizing the embedded systems, or automizing the physical problem using some devices. And the sensors are just like the sense of the human being. Human beings are having different senses, and these sensors are just like those senses. You can compare the embedded system with human being, and the sensors will be like the eye, the tongue, the ear of embedded system. So sensors are sophisticated devices that are frequently used to detect and respond to electrical or optical signal. A sensor converts the physical parameter into a signal which can be measured electrically. You may not understand by the definition. So let me explain what exactly is the sensor. Sensor is something which senses the physical quantity and converts that physical quantity in the form of electrical signal. In other words, if you want to understand, suppose you have oil and you have water. Okay. And by seeing, you are unable to differentiate which one is oil and which one is water. Now you want to differentiate between the oil and the water. We know that the oil is having higher liquidity as compared to the water. So if we have some sensor which can sense the liquidity, based on their liquidity, you can differentiate between the water and the oil. Similarly, take an example. The example is given here. You can watch this here. In this particular, some article is going from one place to another place, and there is a sensor here. The blue one is the sensor that is sensing and telling us how much far that particular box is. So to measure the physical quantity, that is distance, we have some sensor available. Similarly, on your cell phone, you have n number of sensors. Okay, so you may understand what exactly is the sensor. Let us take another example. We have used here the PIR sensor, and if some particular person is crossing that area, it immediately senses and converts that physical movement in the form of electrical signal. Okay, using this sensor, you can give eyes, ears, tongue to your hardware. The second part is the actuator. An actuator is something which converts energy into motion. So actuators are like your hand, your leg, etc. So the actuators can be used to apply a force. An actuator typically is a mechanical device that takes energy, usually energy that is created by air, electricity, or liquid, and converts it into some kind of the motion. So you can see this picture here. These type of the device which converts the energy, one form of the energy in the form of motion, is called as actuator. See the second one. And these are normally the mechanical devices, not the electrical devices. That's all for today. Thank you.